when we talk about the least square regression, there are some things you are supposed to do by hand on the AP exam. I did tell you that you do not have to do this by hand on the AP exam. Only a madman would assign it to you with some points to find R. And someday I might be mad. And in that terms, that means crazy. When you say madman, that means they're crazy. And so I used to always assign a few problems by hand of finding R. I used to always have you do some problems finding the standard deviation of a set of numbers all by hand. I've kind of gotten away with that only because my goal in here is to teach you the concept and to pass the AP exam. But every once in a while, I think it's still good to keep ourselves honest. But there is something on the AP exam. They give you some formulas on the formula chart that if you didn't have all the data, but you were given the standard deviations of X and Y, and you were given R, if you were given R, you could find the slope. That's a formula that's on the formula chart. Probably the next time I see you, I will let you have that copy of that formula chart so you can see what free stuff they give you. So they may give you these things in a chart, and then you can come up with the slope of the best fit line. They also give you an equation for the Y-intercept. And I would like, now I would say the slope equation doesn't look that hard. R times S of Y over S of X. But what if you were doing the slope equation all by hand? What's the hardest part about finding the slope then?
The weird fraction thing.
The what?
The weird fraction thing.
This thing up here? This one?
That, yeah.
Yeah, because if you got to do this by hand, that's a lot of work. But once you find R, you've already found S of X and S of Y because you can't find R without them. So if I was to make this like a test problem, I would first give you a set of X's and a set of Y's, and I would just tell you, find the standard deviation of X's by hand, find the standard deviation of Y's by hand, show all your work. The next thing would say, find the average of your X's. Well, you already had to do that to get the standard deviation. So then I'd say, find R by hand. Well, you already did these and you already did these. Now you just got to go ahead and number crunch, which I know you love doing. That's why you're in this class. Wrong, I know you're not loving it. Then I could say, what would the slope of that line be? Of course, without technology. And you already have R from the top. You already done the SY and S of X. So it's a very simple equation. You take the standard deviation of the Y's. Think of rise over run. You take the standard deviation of Y. That's your Y, difference of your Y's, similar to delta Y over delta X is equal to the slope. Well, you got the standard deviation of Y's over the standard deviation of X's. Then you have to take that answer, multiply it by R that you calculated earlier. Then if I ask you for your Y-intercept, which is A, remember, Y hat does equal A plus BX. Well, that just uses the averages of X's and Y's that you had to do upstairs for the R to find the standard deviation. And then you have to use B, which you just did right here. So it flows. You could do it all. But even if I gave you 5 points that I purposely made on purpose that would have easy averages, 5 points, and asked you to do it all by hand, it would still take the average person in here.
30 minutes?
I think more. I think there's a few of you who would have it all done in probably 20. But they're the ones that are faster than me. So if I did it all, even 5 things by hand, it's time consuming. Is it worth doing? Probably not. What if it was a test grade? Because people are begging me for another test grade before the 9-week courses. That's next week. People are begging me to try to squeak in another test. So, well, what kind of test could I give? You know, that's not, because I'm not going to finish all this material on this bivariate data and regression. But maybe it could be something next Thursday, Friday that I tell you exactly what I'm going to do. You know, maybe I give you one with 3 points as a homework assignment. You do it, and I tell you you're going to have 5 points the next time. So it is something that could give you an easy 100.
That's not bad.
It's not bad. I mean, I'm not saying it's fun. I hate calculation stuff by hand. If I can't do it in my head, and I have to actually like write down subtraction stuff and multiplying, I hate multiplying on paper. I hate dividing on paper. I don't mind doing number sense stuff in my head, but it'd be an easy 100. So I'm kind of leaning towards that as an easy 100. That way, if you didn't have a great test grade on the first test, you could get that average up, and most of it's mechanical. So keep that in mind. You might want to practice those on your own. Practice with just 2 points. And see if you could come up. I mean, everybody can come up with the equation of 2 points with algebra, right? You can find the slope for real, and you can find the Y-intercept for real using algebra. Why don't you try it with algebra, because then you'll know the answers, and then try it with these formulas and see if you could actually do the standard deviation by hand, then find R, then find B, then find A, and see if it's the same answer. Challenge yourself this weekend. Just do it. Just do 2 points. And then you'll say to yourself, I do want that as a test because I know I could do 5 points or 4 points.
So that test should be on basically just this.
I'm thinking about it. That'd be enough. I mean, it's even 4 or 5 points is going to take some people a half hour or 40 minutes. I'm playing with the idea. So if I were you, I would do 2 points on your own. And then you should come up. You all know how to find the equation of a line with 2 points with algebra, right? Anybody not?
What was the question again?
Find the equation of the line between 2 points with algebra. 2, 3, -1, 4. Looks like this. 1, 2, 1, 2, 3. -1, 1, 2, 3, 4 up here. So there's my line. There's my best fit line. Why is it the best fit? It's the same line the calculator will give you because it's only 2 points. Has to go through them both. Okay? So find the slope. 4 minus 3 is 1. -1 minus 2 is a -3. Well, that makes sense. A negative slope. Negative association. So that's easy. How do you find this Y-intercept? That's somewhere up here. How do I find that with algebra? Mx plus b, right? Pick a point, any point. I'll pick 2, 3. 3 equals to the slope, which was -1/3. Bx is 2 plus b, which is my Y-intercept from algebra. Not in statistics, though. B is slope in statistics. So I finish that up. 3 minus 2/3 plus a b. 3 equals minus 2/3 plus b. One more step. Nice job, Sam. 3 plus 2/3. Why are you going, wow, this guy is smart. He always was. He is smart. 3 plus 2/3. And that's okay. I'll probably make it into one fraction instead. So here's my magic trick. 3 over 1. I go 3. I want to add those up. So I'm adding 2 fractions. 3 times 3 is 9. 1 times 2 is 2. 9 plus 2. All over this product, 3. B is 11/3. So the equation is y hat will be equal to -1/3 x plus 11/3. Well, isn't 11/3 almost a 4? 1, 2, 3. Oh, what happened? I moved off? Sorry. It's almost a 4. Not quite, though. So that's just algebra. And I guarantee you, if you do it right with the R formula and the A formula, the B formula, it should come out to the same answer. So even though I picked 2 easy points, you're going to have fraction answers. So you're going to go, oh, it's hard. Well, yeah, it might be, but you can do it. But so anyway, that's just the algebra review. Well, back to statistics. Let's look at our line again with our calculator. Should still be there, right? You didn't do anything to erase it. It should still be there. I didn't give you any homework. That was the data that was in, I forgot to hit enter on that because, there. Because I think one of the steps said we had to delete the outlier, right? So refresh my memory. That's my list. I just put them in again. How do I show the scatter plot?
Go to second, Y equals.
Second, Y equals.
Then press on,
Turn that one on.
and then like it's already on the scatter plot.
Okay, now what?
Now you just keep pressing, now you press zoom 9.
Zoom 9. There's my scatter plot. So I already had that red line. That line is actually, let me just erase that so we can go from scratch because this is very important. To create the equation, oh, what am I hitting that for? Yeah, it was there. So to create the equation, what's those steps?
Second catalog, second 0.
No.
No, it's stat.
Stat what?
Stat 4.
Okay, the word was what? Stat calc? For, I didn't, calc?
No, stat 8.
Oh, it's stat calc.
Stat cal 8.
8. Don't use the 4. It'll work. 4 will work. It'll give you the same line. The problem is when you do some more statistics with that line,
Won't work as much.
the variables change. When you use the other one, A is the slope and B is the y-intercept. When you use 8, B is the slope and A. What happens is those other advanced functions will mix up the slope and the y-intercept on you and you won't know why your answers are wrong. So that's the only reason I can find out that we have to use 8. Now, here's the question I would have to the programmers. Why wouldn't you have just done everything y equals mx plus b and just leave it and then run your programs to operate on that? But
Do you think that they wanted to try to avoid it, like any cross formula? Like they don't want to get the variables wrong?
I don't know. Well, but even the older stats books changed the variables to slope as b. Even before there was programming. So I don't know why the fathers of statistics and mothers who was developing it 100 years ago, why they played the game with it. They could have left it the way it was and made it all the same, but it got changed on us. So
You think they want it to be different?
I don't know what the reason is, to be honest with you. What do I do from here? I got the right lists. Just tell it to calculate it. And you see that thing that flashes on the screen before it gives you the answer? How it actually says Lin regression and has some stuff in there? You got to be really fast to see it. In the old days, that's how we keyed that command in. We would just say linear regression and then we'd have to key stuff in. If you have a TI-82 or an 83, you would have to key in more stuff on the command line. Now we're so spoiled, we got menus for everything. So how do I paste that whole equation into my y equals?
You press Y equals,
I press the y equals.
and then you
Then I do what?
stat. Press stat again.
Nope.
Second stat.
Nope. I press vars because it's a variable that you just created. The equation actually is one big variable that you just created. Actually, if you think about it, isn't y equals mx plus b, isn't y equal to a variable? And isn't x a variable? So aren't these all variables? y1, y2, y3, they're variables. So what variable do I want in there I want the variable of y1 of y1 that I just created. I'm going to put it in there at least. Here goes. Vars. And it came from where? I just did the work. It came from where? Where's my equation coming from? I don't use y-vars. I don't have a y-var yet. I don't have nothing in there. Statistics. It came from stats. And what kind of statistics did I create? An equation. EQ.
And then you put regular.
And what kind of equation was it? What of the equation do you want? Do you just want A? Do you want the R that was created? Do you want R squared? I'm not sure. Well, we have a B in ours. We don't have a C, D, and E. That would be like for a quadratic or a third degree polynomial. All we have is A's and B's. So those come from the equation, but I want the whole equation. The whole equation. And so it pastes it there. Now, I'm glad somebody mentioned vars y1 because we're going to use that in a little bit. So then when I hit graph, it's a pretty nice line. But then he asks us to, in exercise 1, to delete the outlier. So I'm going to go to my list again. I'm not even sure if he told us to graph the line or draw the line on our paper yet. You can check the order. He may not even had us draw the line yet. Because I think now we delete the outlier, which was at 4.6, comma, 160. So all I do is just hit delete one time. That list comes up. Then I got to go over to the 160 and bring those up by hitting delete. And so now the equation that I have here is not going to be the same equation. I'm going to leave it for right now. But let me go and do a new equation. Stat, calc, 8, enter, 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 enter. And look at that, all those things that popped up, L1, L2. You actually had to type that in the old days. I want to paste that one now. That's my newly created statistics. So I go to y equals, and I'm going to put this at y2 just for fun. And again, it's a variable created with statistics. It was an equation that I created, and it was the whole equation that I want. So now when I hit graph, that outlier removed does allow the line to fall down a little bit.
Wait, how did you move the outlier? You just like
I just went to the 4.6 and hit delete. Then I went over to the 160 and pressed delete to make sure the whole ordered pair is gone.
Okay.
It's not a very exciting transformation, but I do want you to realize that that outlier was pulling the line up a little bit. It probably wasn't even an outlier, guys. He said, circle the point that might be an outlier. I don't think it is an outlier. It didn't change the line that much. Hardly at all. So now I don't really need that first equation anymore because he's going to only deal with that second equation, so I'm deleting it. So I only need that red one. So, yeah.
For when, like, put in the line of that space, couldn't you just store it straight up?
Yeah, there's a lot of storing. You mean right from the...
Like from set and Y.
Yeah, there's a lot of other things you can do.
And the alpha Y, and then just put trace 1. And the story.
But where was it at? Was it in memory? Or you're storing it where?
Like, for the Y1, so then when you do it, it would already be here.
Oh, yeah, you can do those things, sure. There's a lot of stuff that the code... Like, I didn't even know that the mode button actually had diagnostic on. I didn't even know that. And I hardly ever press mode. But there's a student insisted there had to be an easier way. Because she even said that. Sir, is there an easier way? And I said, I don't know, there's not. And then she found it. Okay. I don't know everything.
Well, it's also for 84.
Say it again.
It's also for 85. It's near your bottom.
It's at the bottom of where? On this.
On the old one, too.
You have it on there? What old one? What calculator you got?
84 plus.
No, that's not. That's still the newer one. It's your operating system that has been updated at least once, or when you bought it. We never used to update our operating systems, believe it or not. The 82 was the first one, and we never even knew there were operating systems. You used the 82 until it died, and then 8 years later there was an 83. Oh, we got to buy 83s. That's when you got the new operating system. Remember, back in those days, we didn't even have internet. We didn't have that stuff.
What about an 89?
89 is actually an older calculator. It does everything we're doing. The screens are so small.
Mm-hmm.
I don't know how you're seeing it. Using an 89?
No, I have both, but I just wanted to know the difference.
The 89 is considered an algebraic. It actually, if you had calculus, you learned how to do integration, and integration that had you weren't doing it from a number to a number, so you weren't getting an answer. It actually would integrate for you and show you what it is simplified. It actually does derivatives for you. It actually tells you what the derivative is. Like if you just ask for it to do the derivative of sine of x, it'll tell you cosine of x. Our calculators, the 84s, can't do that. We can ask for it to do the derivative of sine of x evaluated at an angle. It'll give me a number. So the 89 used to be the most powerful calculator, and people were saying, that shouldn't be allowed on the AP test. It gives the answers. But the test was made such a way it didn't really help. I haven't seen many people use an 89 forever. Where did you get it?
It's online as a
I don't know where.
I don't know where he got it. I think it was from a teacher.
Yeah, that's as old as the 82, 83 calculators when it came out. It came out shortly right after that. When you see 82 or 84, that's the year they started designing it. But trust me, we never got the 82 in our hands until probably 94, 93. We all math teachers in the state had to be sent to training to learn how to use the graphing calculator, because it was going to be the first time ever going to be used on an Algebra 1 end of course exam. So every one of us who went knew nothing about a graphing calculator. We were all bumbling fools trying to figure out this sophisticated, complicated tool. You would have laughed at us because we were like babies. Oh my God, it graphed it. We were like just so impressed that it can do it. Now you guys don't care. You see more than that on PlayStation. Okay. We already went through how to do it on a calculator, so that was the end of that notes. And let's go back to our example that we started. We did number 2, found the least square regression line. Comment on this association, the strength in the association. I just deleted mine. Do you still have the original equation in your calculator?
Which equation?
The original one before I deleted the blue one?
Yeah.
You have it written? So let me write this in there because you're supposed to put it on there. Y hat was
Oh, I thought you meant like the one from.
Down with the outlier?
the one with the outlier. You have it?
No.
You want like the whole 225.57,
225,
like
4 decimals,
.5737.
plus or minus.
It's plus minus
Yeah, so I'm going to put minus 17 point.
17.5322.
Okay, X. And then he said comment on the strength of the association. So I'm going to write, you're going to see this question all the time. Find R and interpret it. So I'm going to write it as best as I can, because what will get you a 5 on the AP test if you write this. What was R? Do you remember R? Well, you still have it in your calculator. Unfortunately, if you didn't write it down, you actually have to either go rerun the calculation again or go to VARS and ask to pull it up. But it'll only pull up the last equation you created. I know it was like negative 0.99. 7, 7.2. So here's what I would say about it.
We're still in the calculator.
Oh, sorry. Say, I would say there is.
So it's a 0.972.
Okay. 0.972. 72 what?
6. Well,
728.
I never round. I mean, sometimes I round to a percent if it's important, but there is, either way, a very, very strong, remember those words? Very versus fairly versus moderately. There is a very strong, and here's another key thing, negative association
Wait, can you zoom out real quick? Is this for number 2? I mean, number 3?
Yeah, this was 2. It says comment on the strength of the association. There is a very strong negative association between
Between
diver's time
and the depth.
and depth ascended.
Ascended.
Because the diver was ascending. And that height, that Y value, is how far have they ascended,
Yeah.
right? So that's a good interpretation. There is a very strong negative. So now you've got the strength and you've got the direction association between the diver's time and the depth that the diver ascended. Now 3 said, estimate the point you circled, or eliminate the point you circled, and recalculate the equation of the line. Now he says sketch it. So that's the one we're going to put on our paper, the one that I have on my calculator. That's the one that goes on here. So let's get that equation. So most of you have the new equation in your calculator. So y hat now, I'll put y hat new because they'll keep it tracked differently, is, I think it still said 255.
225.
Oh, it's not 255 no more?
I know the other one was 225 as well.
Oh, 225? Oh, yeah, you're right. 225.84
7984.
minus the 17 point.
I think the last decimal number was 1, not 4.
It wasn't a 4. Did you tell me just 4?
It was
Oh, I'm sorry then.
It's fine.
Minus 17 point?
I think it's minus 18 now.
I don't think so. I don't
Did get a
recall.
second, or,
I don't recall that. Oh, it doesn't. Yeah, what's it say? Yeah, it was 17.
Mine says 18. I don't know.
I'm confused with the first one.
Wait,
So does somebody have it in your calculator? Should still be in your calculator. You keyed it in, you graphed it. 17.
I changed it back to the first one.
Oh, you did?
Yeah.
Thanks. I could have all do it, and then I'll delete it together. I guess we could all be on the same page. Who has the new equation? Could I have the rest of the digits?
Like for 17?
Yeah. Yeah.
47, 8.
A4? So it's a little different. Thank you very much. And that's the one that he wanted us to graph. So here's what I would do to kind of cheat. Because it's hard to get it perfect.
Mr. Cartwright.
Yes.
The honor code.
But it's not cheating if you don't get caught. That's what you guys say, right?
I'm gonna internalize that. That's my new mantra. Cartwright has taught me so.
Yeah.
Yeah, wait.
No, it's not cheating. It's to do the best job I can to draw this line. I'm not really cheating. Yeah, because if I look at the line, I don't know where it's going to go. So what I'm going to do is I'm going to use something you have in your calculator called the table. So all I do is second graph, and now I have some X's. Now my X's are different than you because we were looking for different X's yesterday, and somebody taught me how to change your window, how to change these values so you can get more exact to what you want.
Oh,
Well, you go here to second window, it's your table setup. And you can say, where do I want to start? So I can start at 0, and I can say I'm only counting by ones. And that's what I'm going to do right now because I don't care about decimals right now. So once I hit graph now, or second table now, you'll see I just started at 0, and these are all counting by ones. If I'm looking for numbers that are in the thousands place, 3 decimals, I would go second table setup. Maybe I want the answer of 4.567. 4.567. So I'll start at 4 instead. And now, or maybe 4.5 for that matter.
let me go by.
And go 0.001 and see what happens. I wouldn't do this normally. This is really a waste of my time, but look at, if I want to now, I can scroll down and find it. Why did I say 6, 7? I meant
That's just a long.
5.18. I meant 5.23. 4. I meant 4.531. Okay, I got it. 5.31. It's what? Oh, 146.17. That's what I wanted.
Wait, it's still going.
I don't know. Stop. I don't know. If it gets down to that 647,
There you go.
oh, it was getting close to that 647. Whatever. So anyway, I really want to go back to the easy one. I want to start at 0 and only count by ones. Because I'm going to cheat.
Wait, what?
I'm going to go find some easy X's and Y's that might be in here. So I'll start with a 4, and that's a little more than 155. So I go back to my 4, 155. Remember that. You're going to give me the next one. 4, a little more than 155. So I'm going to go in blue. 4 was right here. More than 155 takes me about here, because look at this is 155. So I'm going to take that point. And did anybody do the same thing as me?
Yes.
Can you give me another point? Because you only need 2 and a straight edge, and you will model the line the way he has it on the screen.
8.
8. Oh, well, 8's off my thing.
Oh, 6.
6. 6 is here.
120.
120. Oh, that's perfect. So then if you pick up a straight edge, the side of your calculator, or a paper that you folded 5 times, should be pretty good if you used a straight edge. And there's your Y hat. So that's what I would do on your assignments, is if you got to put your graph on top of it, is find 2 good points. find 2 good points and just use those. All right, so now it's graphed. Question on how we put the graph on our paper.
Sir, for the 225, I got 0.79. I got 0.3605.
For what?
For like question 3,
Oh,
like what? Why mu?
oh, which are those you don't have?
The 225.798.
What did you have?
225.3605.
Do we have a third opinion in this class?
Yeah, I have the same.
As his?
Mhm.
So you want me to change this to same again?
I think, was it correct, like, when we put in the data, some of us put 4.6667.
Well,
Oh,
yeah, but I told you
I
guys,
just put like 4.67.
I said let's keep it rounded to that nearest tenth, that way we all have the same numbers. So maybe that's why.
Okay.
So whatever you found then, fine. It was, Joel was saying how much different he loved that 0.666. And I was okay with just the 1 decimal because you're not going to be able to differentiate on the graph, even those decimal changes. It's too hard. The line's going to look the same. Okay. All right, we did number 3. So number 4 now, use this model above with the point removed to explain the meaning of the slope. This is important because this is going to be asked of you every time you have a problem that is based on linear regression.
The slope
So the
was-
slope would be equals to what?
The foot per minute.
Yes, I'll add that. Foot per minute or feet. But what was the number? It was a negative 17 something.
Oh, okay, that's one. Negative 17.4784.
And the denominator is a 1. So here's what we would write. Now, I had a little trouble yesterday because I'm thinking, how do I make it sound good using that negative? Because the diver is actually coming up. So how can the slope be negative?
If the direction up was negative,
What value is going in the negative direction?
depth,
The depth. The depth.
is getting smaller.
Because he was underwater, right?
Yeah.
He was underwater, I think something like 240 feet, right?
Yep.
And so in the negative direction, the depth is changing. It's getting to a positive, up to 0. Eventually you want it to go to 0. So the value of the depth is,
Negative.
well,
I mean, like, the amount of depth per minute is negative. Like, 'cause you gain.
right. How deep is he per minute is changing. He was a lot per minute deep. Negative just means the direction he was at. He was underwater. So if you were at 240 and now 220 and now 200, that depth is decreasing. The absolute value of it is decreasing. You see what I'm saying? The negative is there because we were underwater. So I'm going to write this out. This is how you would interpret it. The depth, the diver is at,
Is decreasing.
yeah, that's what I was going to say here. Why is all that popping up? Is at, oh no, I didn't mean to do that. Is decreasing
At a rate of
and slope's a rate, so that's good that he's using that word, at a rate of,
17. Should we put the negative?
you don't have to because you use the word decreasing.
Yeah.
See that? You're using the negative. What if you didn't say decreasing? You could have said the depth, the diver
Changes.
is changing. I didn't write that. Is changing, yeah.
At a rate of negative.
At a rate of negative 17, yeah, you could do that. Rate of 17.84
4, 7, 8, 4
feet
per minute.
per minute. Nice. And that gets you a lot of points if you identify your slope. The most important thing about identifying your slope that way is in context of the problem. You mentioned a diver, you mentioned the depth was decreasing and the time was going per minute. Everything is in context. Everything that you answer from now on. That's one of the mistakes some of you did on your test. You came up with an answer, but you didn't put it in context of what it meant. Or you put it in wrong context. For instance, you were to calculate a z-score. Almost everybody, 100%, found it to be 2.4 in that one problem. I don't know if it was your problem or not. It might have been the other classes because you guys got different for responses. I think yours was 2.4. Do you remember that one? The weightlifting and running?
Oh, yeah.
That what?
Wait,
Did you have that one?
No,
we do?
no.
No, you didn't have that problem. Okay.
We had the tips.
Oh yeah, you had tip problem. So they had to find a z-score. You didn't have to find a z-score in your first response, I don't think. Maybe on the other page. But anyway, everybody found it, but it said interpret what that meant. And a lot of people said that the one student, since the z was 2.5 or 2.4, said that they lift weights 2.4 times the other person.
Oh, that's wrong.
That's not what a z-score says. A z-score is number of standard deviations away from the average, meaning that guy lifts a lot of weight compared to everybody else. Because 2.4 standard deviations is really far to the right. Anyway, everything in context. Now describe the relationship between the time and the depth using something we haven't had yet. R squared. So let's teach you that. Back to my,
I mean, you just have to go to
it's,
the regular.
yeah, go back to that same screen. Second quit. I'm going to try that VARS thing. I'm going to try this VARS 5 EQ. Let me pick 7. Let me get my R. Oh, that was 7. That's R. Let me do it again. VARS, statistics, because this is the last thing I had done. EQ, and I need R squared, which is 8. So let's talk about these. The name for R is correlation, coefficient.
Wait, why is my R giving like error?
Maybe you haven't done a linear regression in a while. Or maybe you did something else and you erased that stuff in memory. But that was the last thing I had done, so it's still in my memory. I don't know if you still have yours. You may have to do stat calc number 8 again to get the R squared. But anyway, just to remind you what this meant. This meant direction and strength of a linear relationship. We already talked about that, right? R squared, we did not talk about. So we'll talk about it now. R squared is called coefficient. And I'll pause and everybody says the same thing. Coefficient. Oh, you cheated. Everybody else in all the other classes,
So it's not cheating if you don't get caught.
he got caught.
Oh, you just got caught?
So, coefficient, they thought if that's correlation coefficient, this must be coefficient correlation. No, it's coefficient of determination. Don't worry, they never ask you for those real names on the test. on the, they'll ask you for R and R squared, they won't ask you to name it. They do ask you to interpret the values though. So this is actually a percentage. It's a percentage of variation.
So like each score or
No, it's a percent. It's actually a percent.
I don't know why.
So if you look at it, it's always going to be positive. Because no matter what R is negative, but if you take that R times itself, it turns into positive. This times this is this. R times R is R squared, or the square root of R squared is R. Sometimes they don't give you both. They give you one and ask for the other. So you got to know how to go back and forth. And I'm going to be lazy and round this to 96%. So it's the percent of variation of the,
Why?
in this problem, what's my Y values?
Yeah.
Depth values.
percentage of variation of depth?
Yes. Percentage of the depth values, someone else is reading the definition of what? Within what?
Within a minute.
No,
Oh,
it's of the regression line gave us this line, right? So you're actually reading it, aren't you? You are, because you're the one that read the name of coefficient of determination. Go ahead, read the whole thing out loud, so we can apply it to this situation.
The whole paragraph?
Yeah.
Okay. If, for instance, you're measuring the relationship between the amount of studying one does compared to the duration of test, and you
Is that the
get-
definition of coefficient of determination?
Oh, no.
Oh.
Sorry. R squared, this represents the percentage of the variation in Y that can be explained by the LSRL.
Least square root.
That's very simplistic. The percent of variation of the depth values that can be explained by our line, LSRL, with respect to the time, because that's what we plugged into the line here. So I'm going to add that, with respect to time. That way I've listed my Y values and I've listed my X values.
all right, can you repeat like the whole sentence?
Percent of variation of depth values that, I'll add that word that, can be explained by the LSRL, least square regression line, with respect to time. Not every point in our scatter plot can be explained. It's what happened. Those are the data, the real data. But R is not a 1. Since R is not 1, it's not a perfect line. The data is not perfect.
That's very close.
But it's very strong, remember?
Yeah.
So to say 96%, that means 4% of the data, we don't know where they came from. They're not explained, we can't explain 4% of the data. They just happened. That's what the person saw, or that's what the watch said. But remember, nothing's perfect. There's rounding to the clock. There's someone's watching it, they're pressing a button. So there's going to be errors that occur. Even though it's a perfect linear, if it was, I didn't say it was a perfect linear relationship. Matter of fact, I had some issues when I saw my scatter plot the very first time. I wonder if anybody remembers what I said.
This the scatter plot?
Yeah, what did I say the very first time I saw it?
That's negative.
Why is it not going? Oh, there it is. What did I say about the first time I saw my scatter plot?
It's a lie.
Did I say it was a line?
No, you said it does have some curve. to
Ah,
it.
yeah, see, so it's not a perfect line. So it's not a perfect linear relationship. It has some curvature there
Okay.
that affects it. So 4% of the data isn't being explained. 96% is though. That's why it's a pretty good equation to use right now. But one of the questions later on in exercise 1 asks you, do you have like any misgivings about this equation? Are there any problems with calling this a linear relationship?
I mean, like, if you could roll a ball down that, it's kind
Well, it's very linear-like. But I can think of two issues I have with this equation.
Oh, the question was, explain why a linear model might not be the best to describe this data.
Okay, I can think of two reasons. One that we just mentioned. What was the first thing I said?
It looked like a curve.
The curvature. It's kind of bothering me a little bit. And so,
It's not perfectly linear.
well, hardly anything's perfectly linear. But the curve bothers me. Scatter doesn't bother me as much. Scatter doesn't bother me as much. But a curve pattern scares the heck out of me. Because that means I'd have to use advanced techniques if it was a curve. How do I know if it was really going to be a curve? We only went like 6 seconds. We don't know how long it's even going to take to reach the surface. We're going to do that in a second. How long is it going to reach the surface? Maybe the whole thing is curved, and I don't know. I'm only looking at a small window of time. Maybe it's not really a linear relationship after all. Maybe the best equation would be an exponential. Maybe. But we don't do exponential fitting in this class.
So like the main misgivings is that like we didn't do enough.
Well, we did whatever we had, and that's what life is. Life throws lemonade, or lemons at, no, I hope they don't throw lemonade at you. Lemons at you, you make lemonade.
What happened to you? What happened to you?
Huh?
You threw lemonade at me.
Oh, let me tell you.
There's a story there.
There's a story there. I hate lemonade to this day.
Wait, actually?
All right, back to where, so, let's try to rewrite what we, I just wrote it, so I'm not going to write it again. So we already answered your number 5.
Oh yeah.
What the next set of notes doing here? I think the next set of notes is a review of looking at your equation, finding R, right here. Here's what I want to take you. Using your LSRL. Okay, I'm not going to do their example because they have a different equation than we have. Suppose you want to predict the value of y when x equals to 4. I'll do that with ours. Suppose we want to predict, was 4 one of the values the person actually clocked or not?
No,
Wasn't, right?
it was like 4.6.
Okay, so if I go back to my calculator and I'm looking at it and say, I wonder what my prediction, where's the prediction? The blue dots are what actually happened. 4 never was recorded, so 4 never actually happened. So the line has to be used to predict what 4 possibly could have been,
Oh, so we just
or
trace.
should be.
We just trace.
Well, I can hit trace. So I hit trace and I start moving, and go ahead, you guys keep moving down while I erase this so I can see what I'm doing. 4, I'm at 3.5. Oh wait, what happened?
Wait.
Wait, why did you just press trace?
I did, but it's jumping. What's going on?
So we just had that 4.6.
It's jumping on my scatter plot.
Oh, just press down, press down.
Press up or down, doesn't matter, it'll be on, see now look at, I'm on the line. So pay attention to what you're tracing. So now I'm at 3.25, so I'll keep going to the right. 4 seconds, what's gonna, 4, 3.4. Look at that, keep going.
Can you just press 4?
Well, I didn't want to tell you the secret yet. I want everybody to see, look at, there's a little more than 4, let me go back. There's a little less than 4, so if you really want 4 and you're tracing, just press 4. Just press the 4. And you'll get exactly. Really?
That wasn't me.
I didn't know. It's learned right now.
So there's your exact depth that the diver is going to be in 4 seconds. So now my question to you is, how long is it going to take? Well, let me do another one. Let's do another one. Tell me, no, let's do one more before I do that. I want to know what happens in 10 seconds.
Okay.
Or, yeah, what happens in 10 seconds?
Press 10
Press
seconds.
10.
or minutes?
Oh, verse 10?
Yeah, 10 seconds or minutes, sir. I mean,
Minutes.
Oh, yeah.
Oh. Why?
Increase the window. Increase the window.
Oh, okay, so I'm gonna go to my arrow here. 10 is not one of my integers down here.
X max.
So what I'm gonna do is go back to trace again. I'm on the dots again, looking, I'm on the plot, so I go up, and I'm gonna move. If you press enter at any time, like if I go farther and I press enter, he will regraph it and give me more room out there. Look at now I'm clearly off the chart. So maybe I'll trace it a little more and see if I can get farther over there, because I'm at 6.
Just zoom out.
No, I don't want to do zooming because then it messes everything all up. So there's plenty of line now. Now maybe it's safe to actually, I press up again and press 10. Let's see if I get an answer for 10. I do have an answer for 10. Where am I at underwater? I'm a little farther down than 50 feet and 6 inches down. A little bit.
So now, in order to find like the surface, you just find 0, right?
All right. So my next hard question is, let's switch it around. I don't want to find the y values. I want to find an x value.
Okay.
How long will it take to get all the way to 0?
Well,
The
X
surface.
equals 0.
So you could keep tracing, couldn't you? You could keep tracing until y equals to what?
Y equals 0.
So it's off the chart, so I'm going to hit enter again and say, oh, there, clearly, here's the surface of the water. I see it.
Can we just use the original equation and plug in like 0?
Or
Set it
you
No, you can't plug in a 0.
You can add
No,
0,
so just set it equal to 0.
Yeah, well, that's what we're going to do here, but you you guys that in calculus, we've done all that stuff before. Let me go to 12. Oh, it happened. I didn't hit trace, and I was on the wrong thing. All right, so I can trace it, get close to it, and say, well, it's in that area. It's almost a 0. That's a little more than a 0. That's negative now, so I just jumped it, right? So how do I get exactly there? You've all learned it in algebra. This is called an x-intercept, so it's called a 0. Just ironically, it's called a 0. So you don't do stats, you do second calc. Is that trace or is it the other one? Yeah, there it is. Do you see 0? That will actually find where it crosses the x-axis. And he asks you, well, you need to go to the left of that 0. So I'll go left of the 0. As long as that's a positive number, it's left of it. Hit enter. Go to the right of it. That's negative, so I hit enter. Now he wants me to guess.
Enter again?
That's pretty good, guess. So how long is it going to take to get to the surface?
12 seconds.
Almost 13 minutes.
Oh, 12
Almost, is it seconds or minutes?
minutes.
Was it minutes? Almost 13 minutes. Now-
How far down is he?
He was 240.
12 minutes to get back up?
Remember, you got to go slow
Oh, right.
because of bends. The pressure is going to blow his ears and everything. So here I'm going to switch this up a bit. He's way down underwater, 240 feet. He starts coming up and he realizes his tank is running out of oxygen. So he knows that there's an emergency tank 50 feet below the water. If he can get to that emergency tank, he might be able to survive. So I want to know how long it takes to get to the 50-foot depth. You could do the same thing. You could keep tracing, right? But I guarantee you, I'm not even on the line again. Got it? 50 feet. I'm getting close, close, close. There it is, coming up. Wait, there it is. Oh, I just passed it. Problem is, it's either here or it's here. You see that? I'm bouncing both sides. So I want the exact time. Well, I already hit trace, and I'm close to 50, so how can I find it?
Use the original use the equation, you plug in 50 for y. Or which?
Well, yeah, I do plug in 50, but how do you do that on a calculator?
You don't use the calculator.
Just put 50 where? Just put a 50.
Exactly.
Just put a 50. That's the y value, horizontal line, right?
And you put intersect.
And then when I hit graph,
You get
there it
intersect.
is, there's my 50.
By intersect.
There's my 50. Now I use the, so you guys in calculus, you know we did all this stuff in the AP problems. Stop it. Because other people are gonna go, I don't, they're learning it maybe for the, not first time, because I believe you've had everything I'm doing. But I'll be honest, there's some teachers that don't use the technology as much. So they may not know these tricks. So be patient with the whole class. And you guys, if you think something went too fast because there are people who do know, just yell at us. I won't cry that long. Just tell me. So to find this exact value here, it's called the intersection now of these two functions. So I do again, second calc. There it is, intersect. But now you got to tell it what's intersecting. That line in blue, yes, hit enter. That line in red, see it's in red, hit enter. Now he wants you to guess where the intersection is. Well, I guess it's right over here, so I'll move over to it. And that's pretty close, hit enter. And so to get exactly 50 feet, to save my life, it's gonna take a little more than 10 minutes. I don't even know how many seconds that actually is. It's just, if I can just hold on until I get for 10 minutes, then you have your life saved. Now I'm going to show you, remember how we found those other values at 4 and at 10? You could have done that from the blank screen. You don't want to mess with all those equations? Then you have this power, like I said I was going to show you. You can press vars, go to Y vars, pick your function, and mine was in number 2. Number 2 was my line of the, I shouldn't have hit enter. You do that again. Vars, Y vars, function, number 2, parenthesis, and I want to know how deep was I in 10 seconds. 10 minutes, I mean. So I just put the 10 in parentheses, and he'll plug it in for me. I don't have to trace it. There's my 50.5. 50 minutes and a little more than 30 seconds.
So your end marks you intersection?
No, this is just how deep am I in 10 seconds of swimming? How deep was I after 2 minutes? Yes. Second enter. It don't take as long this time, Sam. You're doing a good job today, so don't. 2 minutes. What if I plug in a 0? What should it say? Should say 240, right? Because that was actually the Y-intercept.
Wait.
Was it exactly though? My line?
20? Did you do 20? That's Y 220?
We said 240.
No, Y0.
Y0, yeah. What if we just say second enter, bring that back up, and put a 0 there? The observed was 240, right?
Yeah.
But the line says, not really, it's 225.36.
Yeah.
That's the predicted. So, within this class, somebody asked about making the Y-intercept 0? First situation, no?
I said directly proportional.
Well, yeah, if it's directly proportional, that would make the Y-intercept 0. So sometimes the researcher might fudge the data to change the equation that this would have given me exactly 240. because we know that's how deep he was when he started. So they forced that point to always be true, and then it's just a more complicated analysis. I think I've covered R squared. Okay, table of data right here. Often when people do this stuff, they don't use a calculator. They use a computer. And all they do is they plug in a bunch of X's and they plug in a bunch of Y's. Then they tell the calculator, the computer I mean, they run a command that says, do the linear regression. Out pops out this printout that comes out with their equation. And then sometimes that's not even there. Sometimes you don't get the equation. Sometimes you do. And if you're lucky, look what it did here. The X was the height of a person, and the shoe size would be the predicted shoe size for that person. So that would be my Y. In this case, he gave us an equation. But what if they didn't? They only give you this. You would have to make the equation. The question is, you're looking for A and you're looking for B. B means slope. A means Y-intercept. Which of those do you think is a constant? The Y-intercept would be the constant. Okay? So I say that because you could look at this and see it. In this case, you can see it. He's not hiding it from you. Look at this value next to the word height. It's right here. Height. Sometimes they don't use the word though. They use a different word. But they always use constant. That stood for the Y-intercept. Now, right now, this report also came out with R squared. Look at it. He gave us R squared. But he didn't give us R. He gave us R squared right here.
What's the difference between R squared and then R squared adjacent?
This is not adjacent. This means adjusted. The computer was thinking, said, computer, I think there's some piece of data in there that I don't want. Like an outlier. So they removed it for you and they created a new R squared for you. We will never use it.
Why not?
We never remove the data for real. And right now, we're not using S. S is the standard error of the line. But what? Our standard error? It's a standard deviation of your points. It's a we're not going to. We don't do that till like the last week of school. So T, we'll use T later on, but not right now. A p-value, we'll use probabilities of something later on. Right now, you just got to know how to create the equation from this printout. If you want to read more about it, here's a nice paragraph talking about R coming from the square root of R squared. He might answer you here, Joel. S, go ahead and read me that paragraph. I don't think he's going to tell you much. Go ahead, read it out loud.
S is a standard error about the regression line. Unlike standard deviation is typical distance, the value lies from the mean. The value of S here is a typical vertical distance a point is from the regression line. If you were to make a prediction of a woman's shoe size based on her height, it would give you an estimate of how much you might be over or under the prediction.
So, standard error is like, how far are you from the mean? How far are you from the line? When you have a best fit line and you got a point that happened here, you need to realize that distance here is called an error.
But it's only the vertical distance, so it doesn't have
It is vertical. It is vertical now because look at it. It's a right angle.
Vertical as in right angle?
Vertical as in vertical as if you take your line like this and you straighten it out so you can see it vertical on it, but the line's still this way. But just pretend that you turned it. I mean, so I just move this thing down and I draw it like this. Still the same distance. By the way, the name for this distance here is called residual.
Okay, so that's standard deviation.
No, that's a residual. You put all your residuals in a table, all the residuals of every point that you have in your scatter plot, and find the standard deviation of all those residuals. That would be your standard error.
So standard error is the standard of all the residuals.
What's that?
The standard error is the standard deviation
Of all the errors. Yeah. Which we don't mess with that. We will do residuals, because if you go to the next page, first word. Okay, this is your preview. Residual. There it is. All right, exercises. We've done almost all of 1. Make sure you do number 6. Number 7. This is the same exercise 1. And 8. 6, 7, and 8.